So we must show this relation, this expression. And for this, we start from this operator, the creation operator. When we apply this in a number state, then we can get n plus 1 under root, and 1 photon is increasing, so n plus 1. And from this, if we find out n plus 1, then this term will come here. And finally, if I write this expression in this form, because this is the left hand side, n plus 1 under root, and this in this term we can write this at the right hand side. So a dagger n plus 1. Now if n plus 1 tends to n, then this expression becomes, because n plus 1 is equal to n, then so this is n and a dagger as it is, and this n minus 1, because we if we place n plus 1 is equal to n, then n must be n minus 1, and this is n. And similarly, if using this condition, then n minus 1, here we will get n minus 2, and this will be n minus 1. And further, this n minus 2 must be equal to n minus 3 and n minus 2. So this process can be continuous, and so on. We can get a dagger n under root, and from n minus 1 we can put this term. So we have n minus 2, and for n minus 2 we can put this value, and this process will be continuous. And finally a dagger, and because this is reducing by one factor, if this n tends to 1, then the next step is 0, because if you look here, this is n minus 1, then n minus 2, and this is n minus 1. So if here is 1, then the lower state must be 0. And finally, if we we can write this in a compact form, a dagger power n and factorial, and we can get this expression. And for this, if I consider n is equal to 1, so it means that 1, which is equal to a dagger 1 divided by 1 factorial, and this can be operated on this vacuum state. And if we apply this operator on a vacuum state, then we must have 0 plus 1 and 0 plus 1. So we have 1 and 1. So 1 photon can be generated using this relation. And for n is equal to 2, we have 2, which is equal to a dagger square divided by 2 pictorial and under root, and here as 0. Now 1 over 2 and a dagger square means a dagger and 0 state. And for this, if we apply the creation operator on this, then we can get this a dagger as it is, and we can get 1. And further we apply this, then we can get 1 plus 1 under root, and here 1 plus 1 is equal to 2. Then this is 2 under root, and here is also 2 under root, so this and this can be cancelled out, and we can get 2 under root. So 2 is equal to 2. So this left hand side is equal to right hand side. If you put a number of photon for any value, for n is equal to 10, you can get 10, which is equal to 10. So the left hand side and the right hand side must be equal.